All right, so we got our first problem here, and what we're going to do is we're going to go ahead and make a list of all the given information to start this problem out. We have a car, it's at rest. It accelerates at negative 8.5 meters per second squared until it reaches a final velocity of negative 25 meters per second. How much distance, really displacement, did the car cover during that period? So that's all the important bits of information in the problem. Let's go ahead and make our list. We have, it's initially at rest, right? So that's our V naught. That's 0 in this problem. We also know our acceleration is negative 8.5 meters per second squared. We have our final velocity, V, being equal to negative 25 meters per second. And we are looking for the displacement, distance, essentially the same thing in this problem. Let's call it delta x, which is unknown. When I look at that, I'm going to go ahead and choose my equations. I'll notice that I have initial velocity, final velocity, acceleration, and delta x. There's no time in my equation, so I will be using our third kinematic equation. V squared is equal to V naught squared plus 2a delta x. Okay, and then I can begin to plug my information in there. I have negative 25 squared is equal to 0 squared plus 2 times negative 8.5 times delta x. All right, so now it's time to bust out that calculator. I have negative 25, and I like to plug it in exactly the same way that it's written, squared. All right, so I'm going to have my 625 is equal to 0 squared is 0 plus 2 times negative 8.5 gets me negative 17 delta x. So after I clean this up a little bit, I get 625 is equal to negative 17 delta x. I'm going to go ahead and divide by negative 17 on both sides, leaving me with delta x is equal to 625 divided by negative 17, negative 36.76. Oops, just meters for our final answer.